Right, yes, we are back again. So we are doing question 4.2 in the June examination that was written in Gauteng on the 9th of June. So let's resume. So 4.2 gives us an exponential graph as it's shown there. And they give us f of x is equal to 1 over 3 to the power x, right? And they say write down the equation of the asymptote of f, right? So let's just delve into that a little bit. F of x is equal to, let's just say, b to the power x plus q, right? So the value, right, of the asymptote is always this. It's always the value of q there. So in this graph, we do not have any value of q, right? We just have the value of b here and x. So we do not have the value of q. So what that means is that our asymptote rather, right, is where y is equal to 0. Because we understand that where y is equal to 0, it's on the x-axis. And we can see, right, so it looks like the graph is touching here, right? But an asymptote is generally a line that the graph approaches, but it will never touch that line, right? So by the given equation, we can clarify that our asymptote there is y is equal to 0, right? So 4.2.2, they ask us to write down the equation of f to the negative 1. So what that means is that we should find the inverse of our graph. So the inverse of the graph is the graph reflected about this line here. This line is goes with the equation y equal to x. So what this means is that wherever y is 1, x is also 1. Wherever y is 2, x is also 2, right? And so on and so on and so on, right? So that's the line. And if we're just to draw a picture here by reflecting this graph that we're given, we'd have something like this. We'd have something like this, right? And yeah, so now let's just complete the question. So we understand that when we're finding the inverse of a graph, we swap the y and x value. So initially we had y is equals to 1 over 3 to the power x. So now x becomes y and y becomes x, right? So we're going to have x, this is for the inverse, right, is equals to 1 over 3 all to the power y. Can you see, right? So now they want us to write the formula in terms of y is equal to, right? So we need to make y subject of the formula. So now that's where we introduce logarithms, right? So want to make y subject to the formula, we always take the exponent and equate it to log. The base stays the base. So we had base of 1 over 3, right? So the base stays the same, right? So we still have 1 over 3 there. And then whatever is left, if it's x plus 35, that's what we're going to have there. So now we just have x in this case. So that's what we have there as the graph of the inverse. So now let's go to the next question. The next question asks us to sketch down the graph of f, of the inverse, right? Of the inverse of f in our answer book and indicate the x-intercept and one other point on the graph, right? So let's look at this. Let's look at this. So now let's just sketch our graph. Let me just sketch the axes. So we're going to have something like that there. And then we are going to sketch our graph, right? So by understanding this, right, we can firstly see that here, the range of this graph, right, is where y is greater than 0. So this graph exists for all the values where y is greater than 0. And also, what we need to understand about the inverse is that the range of original, right, which in this case is our f of x, right, is equal to the domain of the inverse. So the inverse that we have now, right, we're going to have a domain, right? And that domain is going to be x is greater than 0 because here we had y is greater than 0 for our range, right? So that's just something about this graph, right, that we're going to be drawing now. So we understand that all our x values, right, I mean, the graph exists only where the x values are greater than 0. So we're going to have a graph, since we had a graph that looked like this, right? So let's just assume this as our line y is equal to x. So we're going to be reflecting it about that line. So our new graph is going to look something like this. Right? So because that looks like a reflection, as you can see, right? So that's the reflection that we have. So now let's just properly draw our graph. So now that's our y-axis and this is our x-axis. So our graph exists only where the x values are greater than 0. So it means that side of the y-axis. So let's draw our graph. Just like that. So now that we have our graph, they want us to indicate the x-intercept and at least one other point. So you can use the table on your calculator to find the values of this, right? And yeah, you'd find that, where x is 3, I believe, where x is 3, we have a y value of -2, if I'm not mistaken. And yeah, so just check it out on your calculator and we understand that in this graph, right, if we were to find the y-intercept here, meaning that we want to replace x with 0 here, and we understand that anything to the power of 0 is equal to 1. So we're going to have here our y-intercept as what? As 0 and 1. So understanding that concept, right, let's bring it back to the inverse. We understand that the inverse is the original graph, but swapping the y and x values. So it means that our x-intercept here is going to be 1 and 0 because we are just swapping these coordinates, right? So here we have what? 1 and 0, right? So that's our graph there. And yeah. Right, let's move to the next question. We have 4.2.4, right? Then it says, write down the equation of the asymptote of f of -1, where we have x plus 2 there. So what this means is that the graph has been shifted, right? This inverse graph that we've just illustrated has been shifted to the left by 2 units. So whenever it's a plus here, it means we've been shifted to the left. And if it's a minus, it means it's been shifted to the right. So now it's been shifted to the left by 2 units. So now let's try and illustrate that. So here, by the way, here, our asymptote, right, is where x. So our asymptote is where x is equal to 0. Because we understand that the graph will approach this point where x is equal to 0, which is the y-axis in this case, but it will never touch that graph, right? So that's our asymptote there, right? And now they give us, right, a graph, the very same graph, but it's shifted to the left by 2 units. So let's try and illustrate that on our diagram. And we're gonna have something like this, right? The very same graph, but it's been shifted by 2 units. So it means this point, right, shifted by 2 units here, we're gonna have -1 and 0, but they're not asking for the x-intercept, they're asking for the asymptote. So our asymptote was x is equal to 0. Now we've shifted it 2 units to the left. Our asymptote is going to become x is equal to -2. So where x is equal to -2. X is equal to -2, right? And right, so we're done with that. And now they ask us to prove this following equation, right? So now they say prove that f of wara 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 wara, right? So in other words, they're just asking us to prove that the left-hand side is equal to the right-hand side. So in this case, let's deal with the left-hand side as much as we can, and then we're going to go to the right-hand side and see if we can match it with what we've dealt with on the left-hand side. So let's just do that. So let's go. So 4.2.5. This was 4.2.4. So now we're doing 4.2.5, 4.2.5, right? So we have f of, right, we have it like this. We have f of x all squared minus f of negative x all squared, f of negative x all squared. Right, so let's simplify this to the best extent that we can, right? So let's go. Left hand side is equal to our f of x, right, squared. We know that the f of x graph is this, right? So we're given that, right? So now wherever, let's just write that down, 1 over 3 to the power x, right? This all squared, and we're f of negative 1. So this means that we're 1 over 3 where x is negative x, right? And that all squared. So now that we have that, let's try and simplify this. So, we see something now. So here we have a power raised to a higher power. And we understand that the law of exponents tells us that a to the power n all to the power m is equal to a to the power nm, which means that when you are raising a power to a higher power, we multiply the exponents, right? So now that's where we can simplify. Let's try and take this, do this. So we're going to have 1 over 3 to the power of 2x minus 1 over 3 all to the power of negative 2x. So now that's how far we can go there. So we have that. So let's try and see the right hand side if we can match it with this, right? So let's go the right hand side. Let's go to the right hand side. We have f of 2x minus f of negative 2x, right? So we have f of 2x minus f of negative 2x, right? So that's where we have it. That's where we start now, right? So let's go. So what this means is that wherever x is in our formula, we replace it with this. So let's go 1 over 3 to the power of 2x minus 1 over 3 to the power of negative 2x. So we're replacing. And now we see, or no, man. These things look alike, exactly alike. They are congruent, right? So we can see that this is the exact same thing as that. So now we can clarify that the left-hand side is equal to the right-hand side. And that's how we do it. And then, that's when we've proven that the left-hand side is equal to the right-hand side. So we've answered the question. So, hope you understand. If you have any questions, just please comment down below. And thank you so much for watching, guys.